But what voting did we discuss? Hard voting or majority voting. Okay. Let me put this aside now. Now let's look at the overall accuracy. When I train my model and test it on the test data for all these 2000, for each and every observation, you can calculate whether it is right or wrong prediction, and overall you'll get accuracy. Agree or disagree? You build a model. You test it on this first observation. Okay. Predicted value is something that you get. Predicted value is say default. But when you look at the actual value, okay, say actual value also says person will default. It's a right prediction, right? Say you apply this model on the second observation, you take all the inputs, supply to your model, you get the output as person will not default. But say for this observation, actual value is default. So it is incorrect classification. In this way, for all the 2000, you would get how many are correct, how many are incorrect. So number of times you get the correct results divided by overall will give me what? Accuracy. Okay. I get the overall accuracy now. Agree or disagree, friends? So I get accuracy for base learner 1. For this base learner 1, when I apply, I get accuracy. What is accuracy? Maybe 90%, whatever. Then once again, I split the data into training and test. I train the model. I test it on the test data here. Okay, and I get the overall accuracy for base learner 2. Say we got an accuracy of 88%. Now I try out base learner 3. Say accuracy is 92%. How do I combine the results? By taking an average. Simple. If I take an average, it will be called as simple averaging or what voting? Yes. Now, instead of simple averaging, I can proceed further with weighted averaging also. What do you mean by weighting average? That algorithm which gives me the highest accuracy, I give it the highest weightage. That accuracy which gives me the next highest, slightly it will be given less weightage. This will be given least weightage. Okay, that's how it is calculated. By using some normalization, it is done. That's a simple calculation. Okay. Next time I'm missing anything else. Okay. There is, sorry. Any question from me? Weighted average means if an algorithm is giving me more result, I'll give it more weightage. If an algorithm is giving me less result, I'll give less weightage. Common sense. Okay. Yeah, Kavya, please go ahead.
Initially, when we have the sample data, we are splitting it into train and test data, 80% and 20%. Again, for the base learner 2 model, we are splitting the train data again to train and test.
Not train data, data that you have into training and test.
Okay, so I got confused because there also we have train and test data, but test data remains the same, right?
Test data, that is one scenario, Kavya.
Okay.
Where you allow your test data to remain the same. Scenario 2 is you can let your test data change because we are looking at overall accuracy.
Okay.
We are not looking at every record. We are not looking at what is it that the base learner 1 is predicting for record 1. What is it that the base learner is predicting for record 1? What is it that the base learner 3 is predicting for record 1? That is not what we are bothered about. If that is what you're concerned about, then you need to ensure that the test data remains the same.
Okay.
Since you are interested in overall accuracy, you are allowing your test data also to change. So for third base learner, again from this original data, you split that into training and test.
Yeah. Got it, sir. Yeah. Thank you.
Okay, no problem. Now, okay. I would like to take an example where, say we have a two-class problem, whether a person will default or not default. And say you have three base learners, base learner 1, base learner 2, base learner 3. And base learner 1 predicts that there is probably 70% or 75% probability that a person will default. That means there's 25% probability that person will not default. Then base learner 2 might say that there's only 10% probability that a person will default. That means 90% probability that person will not default. Then base learner 3 comes into picture. Say base learner 3 says that there is 15% probability that person will default, 85% probability that person will not default. Now, how do I apply hard voting on this? And how do I apply soft voting on this? Hard voting means in this, using base learner 1, what will be the result? Default. Okay. Then using base learner 2, what will be the result? Not default. Then using base learner 3, what will be the result? Not default. So overall, what will be the output? Not default. That's the majority. If I apply soft voting, what it does is, it is going to take an average. What is average of these three going to be? Anyone? 0.33, right? Agree? Here, what will be the average? Point 7 approximately, or 0.67 to be precise. Agree? Okay. Now in soft voting, what happens is it will take an average. And which class has the highest probability? Not default. So the final result will be, making sense? That's how hard working and soft working works. Okay. All right. Okay. So we understand the difference between hard working, soft working, simple average, and weighted average. We also now understand bagging.